Every major AI company is racing toward the same future. OpenAI, Google, Meta, Microsoft, Amazon. They compete with each other on everything, but they all share the same problem. They cannot build AI, not at any serious scale, without a company that controls the tools they need. And that company is Nvidia. Most people know the broad outline of the story: a gaming chip company, an AI boom, a stock price that became almost impossible to explain. Nvidia went from making graphics cards for gamers to becoming one of the most valuable companies in human history. The numbers are extraordinary, but the numbers and the rise aren't what this video is about, because here's what's harder to explain. Google has one of the deepest engineering benches in the world. Amazon built its own cloud infrastructure from scratch. Microsoft has committed roughly $13 billion to OpenAI. Every one of them is actively trying to reduce their dependence on Nvidia. None of them have managed it. Why? In late 2022, something happened that changed the direction of the technology industry. OpenAI released ChatGPT. Within 2 months, it had 100 million users, faster than any consumer product in history. Every major technology company watched this happen and drew the same conclusion. If AI was the future, they needed to be in it. Now, at scale. The problem was immediate. Training AI at any serious scale requires enormous computing power. And the machines at the heart of every serious AI project, the chips that could actually do the work, all pointed in the same direction: Nvidia's H100. At the time, a single H100 chip cost tens of thousands of dollars. Cloud providers were charging thousands of dollars a day to rent access to clusters of them. And there weren't enough. Companies were waiting months. Entire AI projects were delayed because they couldn't get their hands on the right chips. The biggest technology companies on Earth were in a queue. The answer seemed obvious. If Nvidia couldn't supply enough chips, build different ones, better ones, your own. And some of the most powerful companies in the world tried exactly that. AMD invested heavily in its own AI chip line. Intel brought products to market. Google had been developing its own custom chips, called TPUs, for years. Amazon launched Trainium. Microsoft poured resources into custom silicon. These were not small efforts. These were sustained, serious investments from companies with essentially unlimited engineering resources. So why are all of them still buying Nvidia chips? The answer isn't really about the hardware at all. It's about something that most people outside the technology industry have never heard of. And that secret weapon is CUDA. In 2006, Nvidia released a programming platform called CUDA, Compute Unified Device Architecture. The idea was straightforward. Nvidia's GPUs were powerful parallel processors. CUDA gave software developers a way to write code that could run on those GPUs, not just for graphics, but for any kind of heavy computation. Researchers noticed. Scientists began using CUDA to run simulations. Academics used it for data analysis. And then, slowly at first, a group of machine learning researchers began using it to train neural networks. The results were dramatic. Training that once took weeks was suddenly taking days. Experiments that were previously impractical became routine. The AI research community started building, not just on Nvidia's hardware, but on CUDA itself. Think of it this way. Imagine every architect in the world has spent the last 15 years designing buildings using the same software. Every blueprint, every workflow, every project, every tool. Now imagine someone walks in and says, starting tomorrow, use a completely different system. The challenge isn't learning new buttons. The challenge is that your entire career, your team's expertise, your accumulated projects, your established ways of working, were all built around the old one. That's the position the AI industry finds itself in today. Major AI frameworks, such as PyTorch and TensorFlow, were deeply optimized around Nvidia GPUs and CUDA. So were most of the tools that researchers rely on every single day. Universities began teaching machine learning using CUDA. Research papers assumed CUDA. Open source projects were built for CUDA. And here is what makes this different from a typical technology advantage. CUDA launched before the iPhone existed. For nearly 20 years, a generation of researchers and developers learned to think in CUDA, not because they were forced to, because it was the best option available. And it kept getting better. Layer upon layer of knowledge, code, and expertise accumulated on top of it, which means replacing Nvidia isn't just an engineering problem. It's asking an entire industry, millions of researchers, developers, and companies to abandon 2 decades of accumulated work and start again on something else. That is far harder than manufacturing a better chip. AMD's GPU hardware is genuinely competitive. In raw specification terms, their latest AI chips sit close to Nvidia in certain benchmarks. But AMD's software ecosystem, ROCm, their equivalent to CUDA, is years behind. Developers who make the switch report significant additional work just to get existing code running. Tools that work seamlessly on Nvidia require manual adjustment on AMD. Some don't work at all. The hardware gap is closable. The software gap is a different problem. Google's TPUs tell a different story. These aren't GPUs at all. They're custom chips designed specifically for AI workloads. For certain tasks, they're fast, genuinely fast, but they only run inside Google's own cloud. If you want to use them, you're using Google's infrastructure. For companies that run their own data centers, or companies that don't want that level of dependency on a direct competitor, TPUs aren't a realistic option. Amazon's Trainium is serious hardware. So is Intel's Gaudi. Microsoft has invested in custom silicon, but in each case, the same pattern repeats. The hardware exists. The ecosystem doesn't. Building a chip that approaches Nvidia's performance is an engineering challenge. A hard one, but a solvable one. Building the compilers, the frameworks, the documentation, the tutorials, the community knowledge, and the years of accumulated optimization that make CUDA what it is. That's a different undertaking entirely. And then there's the human problem. The engineers who understand how to build and optimize serious AI systems, the people every AI company is competing to hire right now, built their skills on CUDA. That's what they know. That's what they're fastest with. Switching platforms doesn't just mean new tools. It means accepting that your team will be slower for an uncertain period on a platform with less community support, fewer resources, and a shorter track record. Most companies look at that equation and decide the switch isn't worth it. There is one place where the calculation is different: China. Since 2022, US export controls have restricted China's access to Nvidia's most advanced AI chips. For Chinese companies, the question isn't whether to switch, it's how to function without access. Chinese technology companies, Huawei, Cambricon, and others, are building alternatives. Government funding is significant. Universities are beginning to teach using domestic platforms. It's the most serious attempt anywhere in the world to build an AI ecosystem outside of Nvidia's shadow. And it's serious precisely because it isn't optional. But even there, the dependency runs deep. Many of China's AI researchers were trained on CUDA. Chinese companies built their existing models on CUDA. The transition is real. It's happening. But it's measured in years, and the outcome is genuinely uncertain. Outside China, the picture is less dramatic. AMD is making progress. The gap is narrowing. But narrowing isn't the same as closing. And in the meantime, the demand for Nvidia's chips is not slowing down. Every new generation of AI models requires more computing power. The companies trying to catch up are running toward a target that keeps moving. This channel exists to find the thing behind the thing, the dependency that isn't visible until you look for it. The first Hidden Paths video was about ASML, a Dutch company that builds the only machines capable of producing the world's most advanced chips. A monopoly built on physics. This is a different kind of monopoly. Not physics, not manufacturing, but something that in some ways is even harder to displace. An ecosystem built by millions of people over 2 decades that the AI industry now depends on to function. Nvidia didn't plan this. They built a useful tool. The world built everything else around it. And that changed what Nvidia is. Nvidia may not own AI, but today, every major AI company, OpenAI, Google, Meta, Microsoft, Amazon, still depends on Nvidia's ecosystem to build it, not because they want to, because the cost of leaving is higher than the cost of staying. That's a very different kind of power. If you want to understand how the world actually works, not the visible layer, but what's underneath it, subscribe to Hidden Paths. Next time. Every day, banks around the world send trillions of dollars across borders. Almost none of that money moves the way people think it does. And hidden behind the entire system is an organization most people have never heard of.